Hello, we are going to do notes for Unit 4C Functions and Graphs, Concept C, Graph Analysis. Your learning target for this concept, you need to be able to analyze a function and its graph, determine the characteristics of the function values, increasing, decreasing, and constant intervals, relative extrema, zeros, domain, range, and end behavior. Okay, we'll start with the definitions. The y-intercept of a function is where the graph crosses the y-axis and will always have the coordinate 0, a. And again, a is the value of y where it touches the axis. The x-intercept, or zeros, of a function is where the graph crosses the x-axis and will always have coordinates b0, and b is where it touches the x-axis. A function can be increasing, decreasing, or constant on an open interval. These intervals are given using x values along the x-axis. An interval of increasing is when the function is moving upward. An interval of decreasing is when the function is moving downward. An interval of constant is when the function stays the same y value. Okay, so you can see from the diagram to the right, as we move from left to right, this line is going upward. Okay, and for this other function, as we move to the right, this line is moving downward. Okay, and as you move to the right here, it is neither moving up nor down, so it remains constant. Okay, it's important to note that these intervals are given by the x values of the point where it starts to increase to the point where it stops increasing. Okay, and you will always use parentheses for these intervals, never a bracket, because the point where it changes direction is neither increasing nor decreasing. So we will not include that point in the interval. The end behavior of a function is defined as the behavior of the graph of f of x as x approaches negative infinity to the left and positive infinity to the right. We denote end behavior using the following. X approaches infinity means right on the graph. So if x is going to positive infinity, it's going to the right. X approaches negative infinity means that it's going left on the graph. So we say things like as x approaches infinity or as x approaches negative infinity. So as we're going to the right or as we're going to the left is what that means. F of x approaches infinity means up on the graph. So f of x approaches infinity means y approaches infinity, which is up. F of x approaches negative infinity means down on the graph. So our end behaviors will read something like as x approaches infinity, f of x approaches infinity. So as we go to the right, we go up, is what that means. Okay. A function can have a relative maximum or a minimum. A relative maximum is a point on the graph where the function value is higher than the points immediately around it. A relative minimum is a point where the function value is lower than the point immediately around it. So as you can see on the graph, we have a relative maximum because the points directly to the left and right are lower than the point that is labeled relative maximum. We also have a relative minimum point on the graph because the points directly to the left and right of that point are both higher than the point labeled relative minimum. Okay, now let's do an example. Example 1. Using the graph below, identify the following: domain, range, x-intercepts, y-intercepts, intervals of increasing, decreasing, constant, end behavior, and relative max or min. Okay, so let's start with the domain. The domain are all the x values that are on the given curve. So this curve starts from negative 4, 3, and it remains constant, meaning it is a connected curve all the way to the next endpoint, which ends at 6, 5.5. Okay, so there are no breaks in that curve. It remains constant. It remains continuous all the way through. Okay, so we are starting right here at this point, and it has an x value of negative 4, and it's going to every single point on that curve has a corresponding x value that starts at negative 4 and gets bigger from negative 4 until we get to this point right here, which has an x value of 6. So every x value between the numbers of negative 4 and 6 are on our curve because it is a continuous curve. There are no breaks. It starts at negative 4 and continues all the way to 6 without stopping. Okay, so our interval for this domain is negative 4 is included. So we put a bracket around negative 4 and then comma, and it goes all the way to 6. And it includes 6 is included, so we put a bracket around 6. Okay. In inequality notation, that would be that x is greater than or equal to negative 4, but less than or equal to 6 at the same time. Okay, now the range, similarly, we're looking at the y values. What is the highest y value? Looks like 5.5 is the highest y value. And the lowest y value way down here is negative 8. And if we look at the curve, it's continuous all the way through the entire curve. So every y value is on that curve between those two numbers, negative 8 and 5.5. So for our range, we have the interval negative 8 to 5.5, both included in our interval with brackets. Okay, so y is greater than or equal to negative 8, and it is less than 5.5 at the same time. Every number in our range is between negative 8 and 5.5 inclusive. Okay. All right, now the x-intercepts. Where does this cross the x-axis? Okay, so I don't know exactly where that crosses, but I will approximate that value. This right here, I can see crosses right at 0, and this one right here, again, I don't know exactly where that crosses, but we'll just approximate that value. Okay, so the x-intercepts are the points x equals, or the values x equals, let's say that's a little bit, I think it's a little bit past negative 3.5, but we'll just approximate that at negative 3.5. Okay, and that x-intercept is given by the point negative 3.50. Notice we have a value for x, y is always 0 for our x-intercepts. Okay, our second point is given by the x equals 0, which will be 0, 0. Again, y is 0. And the last one is x equals 5.5 approximately. I don't think those are right at negative 3.5 and 5.5, but they're pretty close. Okay, so we have 5.50. Okay, so we approximated those values because we can't tell exactly where they cross. Okay, for our y-intercept is, looks like the only one is right here at the origin. Okay, so our our y value would be y equals 0, and that is the point 0, 0. So it only crosses the y-axis at one point, which makes sense because it is a function, and functions can only cross the y-axis at one point. Okay, so I want to find the intervals of increase, decrease, and constant. So I'm going to start right here at the far left point. -4, -3 is the far left, as far left as I can go. Because when I'm finding intervals of increasing and decreasing and constant, I want to work from my left to my right. Okay, so as I go on the curve, I'm going to my right. You can see that the curve is increasing from -4, -3, all the way to -2, 4.5. So it is increasing on that interval. So what's really important when you do an interval of increase, decrease, or constant, you want to make sure you use the X values for that interval. So it's increasing on an interval from -4 to -2. So my interval of increase starts at -4 and goes to -2. Okay, so it's increasing from -4 to -2. Okay, now I'm going to look at the next interval. Again, I'm at this point right here, -2, 4.5, but I can see that it changes direction, and as I'm continuing to the right, this curve decreases until I get to that point at 3, -8. It is now decreasing along that part of the curve. So my interval of decreasing is, again, the X values. So I want this number and this number. So I'm going from -2 to 3 for my interval of decreasing. So down here in the interval of decrease, I'm going to do -2 to 3. Okay, so there's my interval. Again, don't forget, being intervals, these are both X values in these intervals. Okay. All right, so now let's go back and figure out, looks like we've got another interval of increasing. So I'm at this point here. That's where I stopped for my interval of decrease, but it changes direction right there and starts to go back up, and it goes back up until I get to this point right here, 4, -6. Okay, so it's going up as I'm going to the right. It's going up. Okay, notice I've been working from left to right this entire time. So that is an interval of increasing. So I need to come back to this box and I need to put our symbol for union. We learned about that in concept B. And we need to add to this interval of increasing because we have another increase here. So we need, don't forget, we need the X values, which is this one and this one. So from 3 to 4. So we're going 3, 4, parentheses. Notice how I've used parentheses every time. When it comes to intervals of increase, decrease, or constant, you're always using parentheses, never brackets. Okay. Okay, so now look at this. We have this interval of constant right here. So we're here at 4, -6, and it goes straight to the right where it doesn't increase or decrease. It just stays constant for my Y value, doesn't change. Okay, that is called an interval of constant. And again, we need these numbers right here. We need the X values of that interval of constant. So it goes from 4 to 5. So we're going to come down here in the box for interval of constant. We're going to put, wrong color. We're going to put 4, 5. So from 4 to 5, it remains constant. Okay, now we have one last interval. As you guys can see, we have this interval that starts right here at 5, because that's where we left off, and it increases all the way up here to 6. So we're using this number here, 4, and that number there, 6. So this interval of interval of increasing, we need to add to this box, so we need another union. So we have 5, 6. And those are our intervals of increase, decrease, and constant. Okay. Now, for end behaviors, this graph doesn't really have end behaviors because remember, by definition, let's go back and look at the definition. End behavior of a function is defined as the behavior of the graph of f of x as x approaches negative infinity and positive infinity. Okay, so this graph is not going to negative infinity or positive infinity, right? It's a finite graph. It stops at -4, it stops at 6. Okay, so this doesn't actually have end behaviors. Okay, now let's take a look at relative max or min. So let's clean up this graph here so we can look at the relative max or min. So remember when we were doing the intervals of increasing and decreasing? Every time we stopped to examine a change in direction because it's no longer increasing, it was going back down. Okay, those typically give us our relative max or min. When it changes direction, so a lot of times that's where the relative extrema is. Look at what we have. Okay, so you can see right here, we have this point right here. That's where it changed direction. It was increasing and then it got to that point and then it started decreasing. So that is our relative extrema. Now, when you do relative extrema, make sure that to the immediate left and the immediate right, the graph has to be either higher or lower than the point in question. Okay, so that point is it's a relative maximum because the left and the right are both lower than that point. Okay, so that is a maximum. So we're going to say max is given by the y value of that point. So we're looking at this point or this value right here. Y is equal to 4.5. Okay. All right. So now we have, let's take a look at this other point. It changed directions right here at 3, -8. Okay. So again, I'm going to look at immediate left and immediate right. You can see that both left and right of the point in question are above that given point. So this is a minimum because the other points are higher than that. It's a relative minimum. Okay. So our minimum point is given by the y value, -8. Okay. So y is equal to -8. And that is example 1. Lots of information there. Okay. All right, let's do example 2. This time we'll see if we can do it a little bit faster. Here we go. Okay. The domain. Look at this. Look at where it's going. Put the arrows at the end because that thing's going forever and ever and ever, right? And you can see that it doesn't go straight up and down. It wouldn't be a function if it did, right? It's slanting out slightly. It's going down much faster than it's going to the left, but it is going to the left forever and ever and ever. Okay. So this domain includes all real numbers, which in interval notation we denote with -infinity to + infinity. And in interval, or excuse me, in inequality notation, that is all the x's that are between -infinity and + infinity. So we say -infinity is less than x is less than infinity. Okay, now the range, I can see that both ends are both going down forever and ever and ever, but it does have a maximum value, right? It has a maximum point way up here. Okay, so with that being said, the curve does not go above that point. So the range is not all real numbers. It's from that point down. Okay, so we need to figure out where that point is. Let's see, this is 4, 5, 6. Okay, so that is about almost 7. So we can approximate that value. It's not exactly 7, but it's almost 7. Okay, so our range is going to be from negative infinity, because it's going down forever and ever, to, we'll say, approximately 7. Okay. In interval notation, we have the y values that are all y values that are less than or equal to 7. Okay. Notice how we don't have a compound inequality. It's just one-sided. It goes from 7 down forever and ever and ever. So every y value that is less than 7. Okay. All right. Where does this thing cross the x-axis? Looks like it crosses right here at -2, at 0, and at +2. Okay. So we have x is equal to -2, x is equal to 0, x is equal to +2. Those are the points -2, 0, 0, 0, and 2, 0. Okay, where does it cross the y-axis? Again, only at one point, 0, 0. So y is equal to 0, the point 0, 0. Okay, the interval of increasing. Interval of increasing. This is a fun one because we know it's as we move from left to right, we're looking for increase or decrease. Where is it increasing? Where is it decreasing? Well, it's going, as we move from left to right, it's going up on this first interval. Okay, so we got to think, where is this thing coming from? I erased it, but remember I had an arrow right down here. Well, it's coming from negative infinity, right? It goes to the left forever and ever and ever. So we can't actually see that happening because we're limited by a finite space, but it goes forever and ever and ever. So this interval is going to look a little different than last time. We know it's increasing, but it's coming from negative infinity. Okay. And it goes to about, let's see, where does it looks like, I don't know, 1, maybe. See, that's 1. This is 1. So that's not quite 1.5. So let's approximate negative 1.3. Okay. So on that interval, it is increasing. Okay. All right. Now we've got a change of direction here. Now from this point, it's going down until it gets to this point right here. So we have an interval of decreasing. Okay. So we started at negative 1.3. And we're going to, looks like it's approximately right there would be what, 0.5, approximately 0.5. Okay, so we're going decreasing from negative 1.3 to 0.5. Okay, now we're changing directions again. Now we're going to increase. Let me change my tool here. We're going to increase until we get to that point right there. Okay, so now we're going back up. So we've got another interval of increasing. So we're going to union with this interval. Okay, and let's see, we started at 0.5 and we are increasing until we get to right here. That's approximately 1.6. We have that interval right there. Okay. Again, this is not exact because we don't know exactly where those points are, but we're given an estimate here. Okay. All right. So now we've got from here, we're going back down. And again, where does it go? It goes down forever and ever and ever. Okay. So that is going to be the interval union with, because it's going down from 1.6 and it's decreasing forever to negative infinity. Okay. Don't forget, notice I drew arrows for all these because these are the points, or these are the values of the x-axis. See how I'm drawing down and figuring out where the x-axis intervals are? That's what I'm trying to find, the values of the x-axis. Okay. All right. Intervals of constant. Hopefully you guys can see those do not exist. We don't have any intervals in which the graph is neither increasing nor decreasing. We only have points where it's no longer increasing or decreasing, changing direction. Okay. All right. End behaviors. Here we go. So we're only looking at the far left and the far right of the graph. Okay. So you can see, let me clean this up a little bit. On the left, the graph is going down. So remember how to write on the left. To write on the left, we write as x approaches negative infinity. Okay, now what's happening as x goes to negative infinity? As x goes to the left, f of x is going down, which we write negative infinity. Down is f of x approaches negative infinity. Okay, then we must do the right. So on the far right side, you can see that it's also going down. Okay, so how do we write on the right side? We write as x approaches infinity. Now to say down again, we're going to write f of x approaches negative infinity. Okay, so there's our end behaviors. Last but not least, let's do the relative max and min. We have this point right here where it changed direction up top. Again, look to the immediate left and the immediate right. They're both below the point in question. So that makes it a maximum, a relative maximum. And it's actually an extreme maximum as well. That is the very highest point. So that maximum is y equals 7. Remember, we want the y value for our maximum. So approximately 7, maybe 6.9-ish. Okay, how about this point right here? Okay, that is looks like both points or both sides of it are higher than that point, which makes this a relative minimum. Okay, so that minimum value is given by the y value, which is y equals approximately -1. Okay, now we have one more, this one right here. And again, to the immediate left and right, the graph is lower than that point. So that point is a relative maximum. Looks like that is at about 1.4. So y equals 1.4. Okay, that's the concept C notes for unit 4C.